In this video, we will talk about equation of tangents and normals. Given y is equal to f of x, when we take the derivative of the function f prime of x, this finds a slope at any given point. So if we plug in an x value over here, let's say, has a value of x1. So then if you plug in f prime of x1, this will give us a slope at this blue dot. The one in green, this would be the slope of the tangent line. So then in order to make this as an equation, we would simply use y is equal to mx plus b. We found out about a slope. Once you have a coordinate x and y to plug it in, you would be able to find the value of b. When it says it's an equation of the normal, that just means the perpendicular line that goes through this tangent equation. So to find a perpendicular slope, sometimes you write it as perpendicular slope m, or sometimes a slope where the normal is. Either way, it means perpendicular to the slope at this given point is always a negative reciprocal. So for example, if we found a regular slope to be 2, a slope of a normal will be negative reciprocal, negative 1/2. To sum up, when you are finding equation of the tangents, you're finding a regular f prime of x, and then plug in the x value to find the slope. To find the normal at that point, you would use negative reciprocal. Normal again means perpendicular. So negative reciprocal of the slope at a tangent line will be your normal. Find the equation of the tangent to f of x is equal to x squared plus 1 at the point where x is equal to 1. We know we have f of x is equal to x squared plus 1. This is a quadratic function where it's concaved up, where it passes the y-intercept at 1. So here we have the curve of a quadratics. Next, at the point when x is equal to 1, you know it needs to pass through 1 and 2. By simply plugging the 1, you get a f of x is equal to 2. So 1 and 2 is going to be the coordinate that you're going to be working with. So to find the equation of the tangent at x equals to 1, we first need to find the slope of this tangent line. In order to do so, we take the derivative of the f of x, which gives us f of x is equal to 2x. And then, in order to find the slope at x equals to 1, we plug in the 1 for the derivative. So simply we get a 2. So this is a problem from chapter 15. Now, we want to find the equation of the tangent. So simply using y is equal to mx plus b, where your 2 turns out to be the slope, the m, we plug in the value of 2 for the m. Now we have y is equal to 2x plus b, and as we mentioned, 1 and 2 are going to be the points that we're going to be working with, because the equation of the tangent passes through 1 and 2, so that 1 and 2 exist on the tangent line, that 1 and 2 also exist on this curve of the x squared plus 1. Plug it in for x and y. We have y is equal to 2, so 2 is equal to 2 times 1, that's your x value, plus b, and therefore b is equal to 0. So finally, the answer to the question is y is equal to 2x. That is the equation of the tangent line when x is equal to 2. Find the equation of the normal to y is equal to 8 over square root of x at the point where x is equal to 4. Earlier this year, we talked about how to graph a function that is 1 over square root of x. This looks like this. So the 8 is just a scalar multiple to this equation. So we will have the similar shape. So here you have the 8 over square root of the x. At x is equal to 4, by simply plugging the 4, we have 8 divided by square root of 4, that's 8 divided by 2, you get an output of 4. So 4 and 4 is going to be the point that we're going to be working with. To find the normal, we first need to find the slope at the tangent line. So y is equal to 8 over square root of x, which we can rewrite this as x to the negative half power. So if we take the derivative, negative half comes in the front, leaving us negative 4x minus 1 on the exponent, so we have negative 3 over 2. This simplifies it into negative 4 over square root of x to the cube. Once again, this can be simplified as negative 4 over x root x. So this is a slope at any given point. We want to find out the slope at x equals to 4. So simply we need to plug in the derivative of 4. So we have negative 4 over 4 square root of 4. So that's going to cancel out, leaving us with negative 1 over 2. So this is the slope, regular slope. To find the slope of the normal, we want to find the negative reciprocal. So negative negative becomes positive. The reciprocal of 1 over 2 is 2 over 1, so it'll be 2. So now we have y is equal to mx plus b once again, and your slope this time, we're looking for the one that's normal. That one goes through perpendicular to tangent. So we have y is equal to 2x plus b. Plug in the point 4 and 4. We get 4 is equal to 8 plus b, and therefore b is equal to negative 4. So the equation of the normal is y is equal to 2x minus 4. Find the equation of any horizontal tangent to y is equal to x to the cube minus 12x plus 2. So let's say the graph of that function looked somewhat like this. Where does it have a horizontal tangent? Horizontal tangents would happen at a maximum and a local minimum over here. Slope of the horizontal line is equal to 0. So in order to talk about a slope, we need to take the derivative of the function. So y prime is equal to 3x squared minus 12. Where do we have a horizontal tangent? So horizontal tangent, the slope has to equal to 0. Now solve for x. We can pull out the 3, left with x squared minus 4 is equal to 0. So it factors out as x plus 2 and x minus 2. So at x equals to negative 2 and positive 2, that's where the slope is equal to 0. To find the equation of the horizontal tangents, let's go back and think about this graph one more time. You have the x and y axes. You have a curve that looks similar to this. At negative 2 and at positive 2, the slope is equal to 0. To figure out the y values of this function, we would plug it back into the original equation. When x is equal to -2, we have a y value of y is equal to -2 to the cube minus 12 times -2 plus 2, which turns out to be -8 plus 24 plus 2, and this returns the value of 18. So when x is equal to -2, your y value is equal to 18. So the equation of this tangent line would be y is equal to 18. For the other tangent line, you would plug in +2. Y is equal to 2 to the cube minus 12 times 2 plus 2. Here you have 8 minus 24 plus 2, which returns the value of -14. So when x is equal to +2, your y value is equal to -14. So these are two equations of the tangent line that's horizontal. Show that the equation of the tangent to y is equal to ln of x at the point y is equal to -1 is y is equal to ex minus 2. So here we're given y is equal to ln of x. That has a graph of when ln 1, you're at 0. So it needs to pass through 1. And it has a shape that looks similar to this. So when y value is equal to -1, now that's interesting. Normally it's the x value that's given, but this time they're giving you the y value to be -1. How would we find the x value at that point? Simply plug it in. -1 is equal to ln of x. ln of x is equal to log e of x. So e raised to the -1st power is equal to x. So that point is e to the -x for the x value. For the y value, you have -1. Now, we want to find the equation of the tangent at this point. So equation of the tangent looks like this. And to find the equation of the tangent, first we need to find the slope. That means we need to take the derivative of y. Y is equal to ln of x, so y prime, the derivative is equal to 1 over x. To find the slope at x is equal to e to the -1, you would simply plug it in. So the slope, y prime, at 1 over e to the -1st power, that's equivalent of 1 over e, so the slope is equal to e. That is your slope. Now, to find the equation of the tangent line, we would use y is equal to mx plus b, where your slope is equal to e, so y is equal to ex plus b. And we know the point. The point is e to the -1st power and -1. So -1 equals to e times e to the -1st power is 1 over e plus b. Here it'll cancel out. You're left with -1 is equal to 1 plus b. Therefore, b is equal to -2. So finally, the equation of the tangent line at x equals to e to the -1st power will be y is equal to ex minus 2, which is what we needed to show. Find the equation of the tangent to y is equal to tangent of x at the point where x is equal to pi over 4. You don't necessarily always have to draw a graph, but I find it's helpful to draw a graph a lot of times. To graph y is equal to tangent of x, we know we have an asymptote at pi over 2. X is equal to pi over 2, and x is equal to negative pi over 2. And then the graph of the tangent passes through the origin, and it looks like this. So at x is equal to pi over 4, which has to be somewhere in here, what is the equation of the tangent lines? Well, when x is equal to pi over 4, what is my y value? Tangent of pi over 4 is 1, because it's the root 2 over 2 over root 2 over 2. Now, to find the equation of the tangent, we would take the derivative of y is equal to tangent of x. So y prime is equal to 1 over cosine squared x. By plugging in pi over 4, because that's the x value, we would find the slope of the tangent line. So slope is 1 over cosine pi over 4. The whole thing is being squared. So here we have 1 over cosine of pi over 4 is root 2 over 2. When you square it, you get 1 over 2 over 4, which is 1 over 2. 1 over 2 is equal to 2. So the slope of this equation of the tangent will be 2. So we have y is equal to 2x plus b. The x and y coordinates are, when y is equal to 1, you have 2 times pi over 4 plus b. Simplifying, we have 1 equals to pi over 2 plus b. Solving for b, we have 1 minus pi over 2 is equal to b. Sometimes they are in fractions, and if you are not allowed to use a calculator, leaving the b in terms of this is totally fine. Final solution would be y is equal to 2x plus 1 minus pi over 2. Find the coordinates of the points where the tangent to y is equal to x cubed plus x plus 2 at 1 and 4 meets the curve again. So let's say that our graph looked somewhat similar to this. At 1 and 4, you'll get a tangent line. And then it's asking, find the coordinate where this tangent line meets the curve again. So maybe it might have 1 more intersections, 2 more intersections, but the idea is finding the equation of this tangent line at 1 and 4. In order to do so, first we need to take the derivative of the y. So y prime is equal to 3x squared plus 1. By plugging in the 1, we would get a slope of the tangent line. So slope of the tangent line is equal to 3, and 1 squared is just 1 plus 1. So we have 4. So y is equal to 4x plus b. And by plugging in the point 1 and 4, we'll be able to solve for b. 4 is equal to 4 plus b. Turns out p is equal to 0. So y is equal to 4x is the equation of this tangent line. So the equation of the tangent line, the one in blue, has an equation of y is equal to 4x. Where is this y is equal to 4x intersects the curve again? In order to solve for this problem, we would set the curve equal to the line. So we have x cubed plus x plus 2 is equal to 4x. Moving everything onto one side, we get x to the cube minus 3x plus 2 is equal to 0. Unfortunately, this is not factorable, so we would have to graph. Put this equation onto y1 on your graphing calculator. Put this equation into y2 of your graphing calculator. See where the curve intersects on calculators. So you would usually go to second calc, go to 0 on your TI-84, and turns out you would have 1 and 4 as one of your intersections, which is given to you, and then the other intersection happens at -2 and -8. Find the equation of the tangent to y is equal to x squared from the external point 2 and 3. What does the external point 2 and 3 mean? We have the graph of y is equal to x squared, which is the concaved up curve. Then we have, when x is equal to 2, the y value on this curve has to be 4. However, 2 and 3 lies outside of this curve, therefore it's called an external point. To find the equation of the tangent from the point 2 and 3, we need to think about what kind of tangent lines could be formed. First one might be the one that passes through here and pass through 2 and 3, so somewhere in here. And then another one may be the one that's going this way. Looks like a horizontal line, but it's really not. It has a slight slope. So we get 2 points on this curve that we need to consider. Let's call this as line 1, and let's call this as a line 2. Any point on this curve, the black curve, could be represented as if you have an input of x, your output would be x squared. And that's true for any of the points on this curve. To find a slope between these 2 points, the slope is equal to the change in y over change in x. So x squared minus 3 over x minus 2. We can also find a slope using the derivatives. Y is equal to x squared, so y prime is equal to 2x. They both mean the same thing. The slope at any given point could be represented as a 2x. A slope using any point on this curve, and particularly to the point 2 and 3, could be also represented as the fraction over here. So we're going to set them equal to each other. X squared minus 3 over x minus 2 is equal to 2x. Now cross multiply, you have x squared minus 3 equals to 2x squared minus 4x. Here, moving everything onto one side, you get x squared minus 4x plus 3 is equal to 0. Factoring it out, we have x minus 1 and x minus 3 is equal to 0. So at x equals to 1 and at x equals to 3, that's where the intersections in blue will happen. So when x is equal to 1, so this will be 1 and a y value something. And then this one on the top will be 3 and y value of something else. To find the y values on this curve, simply we would plug it in. So 1 and 1, and the other one will be 9. Now we have these 3 points that we are going to use to find the equation of the tangent lines. Let's look at line 1. L1 deals with points 1, 1, and 2 and 3. At point x is equal to 1, the slope has to be, plug it in, 2x is the slope at any given point. So when x is equal to 1, your slope has to be 2. So y1, the equation is y is equal to mx plus b, but your m, the slope is equal to 2, so 2x plus b. Plug in the x and y value of 1 and 1. 1 is equal to 2 plus b, and we can find the b is equal to -1. So the equation will be y is equal to 2x minus 1. Using the same logic, we will find the equation of the line 2. When over here, when x is equal to 3, the slope, again, by plugging into a 2x, the any given point, especially when x is equal to 3, your slope is 6. Therefore, y is equal to mx plus b again, and this time your slope is 6x plus b. The point on this curve is 3 and 9. So by plugging in 9 is equal to 6 times 3, that's 18, plus b, you get b is equal to -9. So another equation of this tangent would be y is equal to 6x minus 9. So the two equations of the tangents from the external points will be the ones in the boxes.